Students, next part of atomic structure that we are going to study in this lecture number 3, the wave nature of electron. As we have studied that the electron behaves as a particle and also as a wave. So this dual nature of electron can be studied. Now, according to de Broglie, the moving electron had waves of definite wavelength associated with them. Again, this has been further explained by Davison and Germer in 1927. They demonstrate the physical reality of the wave nature of electrons by showing that a beam of electrons could also be diffracted by crystals just like light or X-rays. Now they observed that the diffraction patterns thus obtained were just similar to those in case of X-rays. It was possible that electrons by their passage through crystals may produce secondary X-rays which would show diffraction effects on the screen. Thomson ruled out this possibility, showing that the electron beam as it emerged from the crystals underwent deflection in the electric field towards the positively charged plates. Now, what is this Davison's and Germer experiment? So you can see in the diagram also. So they have studied the scattering of slow moving electrons by reflection from the surface of nickel crystal. In their experiment, electrons are obtained from a heated filament and passed the stream of electrons through charged plates kept at a potential difference of VESU. So you can see in the diagram that is the nickel crystal and this electron detector and the scale that you can see. So if you see here, this angle theta is measured here. Here this nickel crystal is there. So the electrons are diffracted. You can see here diffraction pattern of the electron. So if you see here, the electrons detector measures the angle of diffraction theta on the graduated circular scale. Now we know the Bragg's diffraction equation, that is lambda is equal to d sine theta, that is lambda is wavelength, d is the constant and theta is the angle of diffraction. By substituting the experimental value of theta in Bragg's equation, lambda is equal to d sine theta, the wavelength of electrons can be determined. So this wavelength is same as that of calculated from equation number 3. Thank you.